we have the infinite series of natural log of n divided by n to the third, and we want to use the integral test to show that this infinite series converges. And once again, if we want to use the integral test to show that this series converges, then we need to show that the corresponding integral of f of x dx, this integral right here, converges. So let A sub n be the sequence, and f of x be the corresponding function. And we need to show that in the integral of f of x converges. This integral will be the function. So f of x is this function right here. And then we write this with using limit notation. So this becomes and in the place of infinity we have b. So it'd be 1 to b, and then b approaches infinity. And then the antiderivative of this, if we look on the table of integrals, then we will find a formula similar to this. Antiderivative of ln of x divided by x to the third is negative 1 minus 2 ln x divided by 4x squared. This formula is on the table of integrals. So now this becomes the limit, and then the antiderivative of ln x divided by x to the third is this. And then we need to evaluate from 1 to b. And so this becomes this. And so now in the place of x, we have b. And then minus, in the place of x, we put 1. And then let's simplify this a little bit. Ln of 1 is just 0, and so right here we have negative 1 minus 2 times 0, which is just negative 1, and then the bottom is just 4. And so for this part, we just get negative 1, 4. But here we have a negative minus, and so this becomes a plus and plus. And then as b approaches infinity, we have ln of b divided by b squared. And so let's find the limit of this quantity right here. So we want to find the limit of this part as b approaches infinity. And so as b approaches infinity, ln of b will approach infinity. And since I have a negative, we have a negative here. This becomes negative infinity, and then minus 1 minus infinity, it'd be just negative infinity. And then the bottom as b approaches infinity, this will approach infinity. So we have infinity over infinity, and therefore we can apply L'Hopital's rule. So this becomes this. And then L'Hopital says that the limit here is the same as the limit of the derivative of the top and derivative of the bottom. So this is derivative here is -1, and then of -1 is 0, and then -2 times ln over b, the derivative is just 1 over b. And then the bottom, we just get a ab. And then we can arrange things a little bit. This will be a -2 over b. And then -2 over b divided by AB will be -2 over AB squared. And as b runs to infinity, we get a -2 over infinity, which is 0. And so so what we get here is this: the limit of this part is 0, and then plus 1, 4, which is equal to 1, 4. And so this integral right here converges to 1, 4, and therefore by integral test, this infinite series converges also. And one more time, the infinite, this integral right here, the integral of 1 of ln x divided by x to the third from 1 to infinity, this integral is 1/4, meaning the graph between the area between the graph of ln x divided by x to the third and the x-axis is equal to 1/4. This is the graph for ln x divided by x to the third, and 1 is right here. When x is 1, you can see that you get 0, so 1 is right here. And so the integral from 1 to infinity of ln x divided by x to the third is this area right here, from 1 to infinity. And that area from 1 to infinity is equal to 1/4. And therefore, the integral test says that this infinite series converges. And one more time, it does not say that this infinite series converges to 1/4. The 1/4 is just the area corresponding to this integral. And so this infinite series converges, but it converges to another real number, not 1/4.